Hello everyone, so today we'll talk about D and F block elements and we do questions from the D and F block. So this video is for the PU students and state board students. Okay, so let us talk about the first question. First question is, what are the interstitial compounds and write any two properties. Okay, first, what do you mean by interstitial? The compound obtained when small atoms like hydrogen or carbon are trapped inside a crystal lattice of metal. Suppose you have a crystal lattice of metal. Metal is in a form of lattice. Okay, so what happen? Atoms have arrangement in a lattice, and now what happen? Inside the lattice there is lot of space. That space is called as void or interstitial space. Okay, so when metals have arranged themselves, there inside there is a space called as interstitial space or called as void. In that space, sometimes what happens, small atoms like carbon and hydrogen are trapped. So these compounds are formed and these are called as interstitial compound. If we talk about their important properties, okay, too, so these compounds have very high melting point. So these compounds cannot be melted easily as compared to the metal. When you add these atoms, their melting point will increase, and these compounds are chemically inert in nature. Because they are very stable, they does not react with any other element and they are stable or called as inert. Second question, how is potassium dichromate is manufactured from the chromite ore? This is very important question. Okay, first you should have a chromite ore. So we have taken iron chromite and you will react with sodium carbonate and in presence of free air. Okay, so free oxygen you will get from the air and you will do the reaction, and when you will react, result in formation of ferric oxide and you will get an important compound called as sodium chromate plus 8CO2. Remember, sodium chromate color is yellow in color. You will separate the precipitate sodium chromate, then sodium chromate you will react in presence of acid. You can take any acid, but we have taken H2SO4. So in presence of H2SO4, it result in formation of sodium dichromate, which is orange in color. Okay, plus Na2SO4 and water is released. So sodium dichromate which is formed, you will react with the KCl. So what happen? This K will displace the sodium from the sodium dichromate, result in formation of potassium dichromate plus NaCl. So this compound is called as potassium dichromate and it is orange in color. Next question is, how is potassium permanganate is manufactured from MnO2 or also called as pyrolusite ore? So you have pyrolusite which is MnO2. You will react this in presence of alkali like KOH, NaOH and in presence of oxygen, result in the formation of potassium manganate. Okay, so remember, manganate ion is MnO4 2 negative. So MnO4 2 negative is potassium manganate plus water is released. So potassium manganate is green in color. Okay. Now what you have done, you have taken potassium manganate plus acid. You have taken any acid. So it will react and result in formation of potassium permanganate. In potassium permanganate, MnO4 negative. So potassium permanganate is formed plus MnO2, H2 and 4. So this compound is dark purple in color. Next question is question number 4. What is lanthanoid contraction and mention the cause of it? This is very important question. What do you mean by lanthanoids? So when the filling of the lanthanoid series starts, what you will see, the gradual decrease in atomic and ionic radius from lanthanum to the lutetium. So whenever there is filling of the 4f orbital starts, so remember 4f represents the lanthanoid. So what happens as you move across the period, what you will see large decrease in the radius. So this decrease in the radius from the lanthanum to the lutetium is called as lanthanoid contraction. Now mention the cause of it. So what is the reason? So what happens as you electrons you will start filling in 4f orbital. What happen? 4f orbital show poor shielding effect. What do you mean? So when electron enter in the 4f orbital, what happen? Nuclear charge is also increasing because atomic number is increasing. So the atomic number increase causes nuclear charge to increase, and these electrons of the 4f does not repel the outermost electron. As a result, outermost electron are attracted toward the nucleus. So what is happening? As number of filling of the 4f orbital increases, nuclear charge increases and it will attract electron toward itself. As nuclear charge increase around the series, so size will decrease. So this is the diagram. You don't have to remember the diagram, so just remember. So from lanthanum, what happens? Suddenly there is large decrease in the size to the lutetium. Why it is happening? Because of the filling of 4f orbital, which has poor shielding effect. So this is called as lanthanoid contraction. Question number 5th. Give the two consequences of lanthanoid contraction. So what are the consequences which happen because of lanthanoid contraction? We have already discussed what is lanthanoid contraction. There is decrease in the size in the lanthanoid series. First is basic character of oxides and hydroxides. First thing you have to remember, as you move across the period, what is happening? Size is decreasing from La to Lu. Lanthanum to lutetium, size is decreasing. As size is decreasing, always remember, according to the Fajan's rule, if an element having or metal having low size, the covalent character will increase. So remember, left to right, covalent character increases. Next, if we talk about their basic character of the oxides and hydroxides across the period, it will decrease. Why this happen? Because lanthanum size is bigger but lutetium size is smaller. So the bond between the lutetium and OH is stronger because size is small. Here bond is bigger. So it is easy to break the lanthanum bond. So as a result, lanthanum is more basic because it can release OH negative easily. Next we talk about, this is very important, this question can be asked separately, similarity of the ionic radius of the second and third transition series. So we are talking about the D block elements. So this effect also D block element, because of the lanthanoid contraction, third transition series become very small in size. Why it happens? Okay, so if you look at this graph, this is, suppose this is 3D series. Okay, this is 4D series and this is 5D series. So this 3D is called as first transition, 4D is called as second transition, and 5D is called as third transition series. So what happens? As you move from 3D to 4D, size will increase normally. But as you move from 4D to 5D, what happens in 5D? In 5D, the filling of 4f orbital also starts. Okay? Because of the filling of 4f orbital, what happen? Because length जो 4f orbital is there, that will show less shielding effect. As a result, the size will decrease, and 4D and 5D series has almost the same size because there is a contraction of the 5D series. So this is called as second series. So this is called as first, this is second and third. As a result, second and third series has almost same radius. If you look at the example, you have hafnium and zirconium. So HF and ZR has the same size. This is of the 4D and 5D series. NB and TA, MO and W has identical size. So remember, as you move from 3D to 4D, size will increase. But as you move from 4D to 5D, in 5D there is filling of 4F starts and there is a contraction of the radius. As a result, second and third series, which is 4D and 5D series, has almost same size. Next question, question number 6. Give reason why actinoids show variable oxidation state. What happen in actinoids? Due to comparable energy, in actinoids you have 5s, 5f, 6d and 7s. All these three orbitals has equal energy. As a result, electron can jump from one orbital to the second or second to the another orbital. Because jumping of electron is easily, so what can happen? Result in formation of variable oxidation state. So elements can have, because of same energy, electron can jump from one orbital to another and they have variable oxidation state. Next question, give reason why transition elements show color compounds, that is copper is colorless as zinc and colorless. So first we talk about why transition elements show color. Okay, so this is due to DD transition. So if you have studied the coordination compound, we have studied that d orbital split into two parts. Okay, so because of the splitting of the d orbital, this is called as electron can jump from one d to the another d orbital, that is called as DD transition. So what happens? When a visible light falls on a compound, it absorbs certain radiation and transmit remaining one. Okay, so whenever light, suppose you have D complex, like these two complexes are there, D complex. So what happens? Electron will jump from one to the another complex, D complex. Okay, as a result, it will absorb some radiation and it will emit other radiation. The radiation which it has emitted, that is the color of the compound. Okay, and another important thing you have to remember, the compound should have unpaired electron. Okay, only when there is unpaired means single electron should be present, then electron can jump from the lower d orbital to the high d orbital, then it will show color. If there is paired electron, then no color will be shown. If d has 0 electron, again no color will be shown. Suppose you have copper 2 plus. If you write the electronic configuration of copper is argon 4s2 3d 9, but it is 2 plus, so you have to remove 2 electron from the 4s. As you remove 2 electron, you have 3d 9. If you write there in the form of boxes, you will see the last electron is unpaired, so that's a result copper will show color. Whereas zinc plus, if you look at zinc plus, as you remove 2 electrons from 4s2, you have 3d10, so all electrons of zinc plus are paired. All electrons are paired. As a result, zinc plus does not show any color. Next question is question number 8. Give reason why manganese exhibit higher oxidation state of +7 among the 3D transition elements. So manganese, if you see in the 3D series, it has the highest oxidation number of +7. So why it is so? The reason is because of its electronic configuration. If you look at the electronic configuration of manganese, it is 3d10 4s2. In 3d orbital, it has 5 unpaired electrons which can do bonding, and it has 2 4s electrons. So all these electrons can take part in the bonding. Total 7 electrons can take part in the bonding, and 3d and 4s electrons energy are almost same. So because 3d and 4d are close in energy, and it has maximum number of electrons to lose and share, as a result, so it has total 7 electrons to share. As a result, it shows +7 oxidation state. Next question. Copper 2 plus is paramagnetic, whereas copper plus is diamagnetic. Remember, paramagnetic means it has unpaired electron, diamagnetic means it has paired electrons. So if you write the electronic configuration of copper, it is Ar argon 4s1 3d10. This is of copper. If you write of copper plus, in copper plus 1 electron will be removed from the 4s, you get 3d10. So all the electrons are paired. As a result, if all electrons are paired, the substance will be diamagnetic. So copper is diamagnetic, whereas in copper 2 plus 1 electron is removed from 4s and 1 electron is removed from 3d. As a result, if you see, it has 1 unpaired electron, and because of 1 unpaired electron, it is paramagnetic in nature. Next question. Give 2 examples that show KMnO4 is an oxidizing agent. Oxidizing agent is a compound which oxidizes the other compound. Suppose you have MnO4 negative, it will oxidize ferrous, which is Fe2 plus, to the ferric Fe3 plus. So it acts as a oxidizing agent. Similarly, suppose you have MnO4, what it will do? It will oxidize iodide ion, which is I negative, to iodine, which is I, from -1 to 0. So what is happening? There is increase in oxidation number, so this is also getting oxidized. So these 2 examples show that KMnO4 can act as a oxidizing agent. Next question. Transition elements show catalytic property and give 2 reasons. So lot of catalysts you will see which are transition elements or their compounds. So why transition elements will show the catalytic property or they act as a catalyst? First reason, because of their variable oxidation state. So transition elements have more than one oxidation state. As a result, what they can do? They can form unstable intermediate compound. So during a reaction, what they can do? They can react with the reactants and they can form unstable product, and this unstable product provides new path with a lower activation energy. So they will go through lower activation energy and then they will convert into product. So remember, in order to convert reactant into product, you need high activation energy. So when you will react with transition element, they will form an unstable compound which is in between compound, and they will lower the activation energy. Next, because of presence of vacant d orbital. Because of presence of vacant d orbital of the transition elements, what can happen? The substrate can get easily attached because of bond formation in the d orbital. As a result, it will increase the surface area. Because of increase of surface area, catalytic property also increases. Next question, question number 11. Why Sc3 plus salts are colorless whereas chromium 3 plus salts are colored? First, electronic configuration of Sc 3 plus. So what will happen when you remove 3 electrons? So its electronic configuration will become 3d0. So it has 0 electron in the d orbital. As a result, d orbital is empty and it has no unpaired electron. Because of presence of 0 unpaired electron cannot jump from lower to the higher orbital. As a result, these compounds are colorless. Whereas Cr3 plus, if you look at chromium 3 plus, what happened? Its electronic configuration is argon 3d3. So it has 3 unpaired electrons, and because of presence of 3 unpaired electron, it can show dd transition, or these compounds can show color. Next, calculate the spin only magnetic moment of Fe2 plus. So first we write electronic configuration of iron, which is 4s2 3d6. So when you will write Fe2 plus, so electronic configuration will become 3d6. Okay, so in 3d6, if you write 3d6 electrons, what you will find? You have 4 unpaired electrons, so n will become equal to 4. So first, for calculating magnetic moment, you have to find how many unpaired electrons are present. So here 4 are present. Then you will use the formula of magnetic moment, under root of n plus 2. So you will substitute the value 4. So 4 bracket 4 plus 2, 4 into 6 is under root 24, and 4.9 Bohr magneton. So 4.9 will be the correct answer. Next is question number 13. Which element of the 3D exhibit maximum oxidation state? So remember, in 3D series we already talked about manganese. Manganese has 3d 5 and 4s2, total 7 electrons. As a result, what happens? It can exhibit oxidation state from +2 to +7. Next question is, why zinc is not considered as a transition element? So why zinc? Zinc is part of a D block, but zinc we does not consider as a transition element. So remember, there are 3 elements in D block, which is zinc, cadmium and mercury. So all these 3 elements have fully filled D orbitals. Okay, so they have D10 configuration. Because they have D10 configuration even in ground as well as in their oxidation state, so what happens? They have fully filled d orbitals and they don't show any property, whereas other elements in their oxidation state, they have unfilled orbitals or unpaired electrons. As a result, they can show color, they can form bond with d orbitals, and they can show catalytic property. So in zinc, cadmium and mercury, because there are D10 electron present, they don't show any reaction. So that's why they are called as non-transition elements. Question number 14. What is the trend in melting point of the transition metal in series? So as you move from left to right, what you will see? You will see the melting point will increase towards the middle. And then if you move further, then melting point will decrease. Why this happens? So the melting point of transition metal rises maximum at the middle. So at the middle of the series, you have 3D, 4D, 5D series. So chromium, molybdenum and tungsten will have the highest melting point. Why it happens? Because all of them have 5 electrons in the d orbital, which is unpaired electrons. Because of this unpaired electron, these metals can bond with themselves. So chromium can bond with chromium, which bond is called as metallic bond, and that bond will be stronger. Okay, and then fall regularly as the atomic number increases. As you move further right, what happen? Melting point will decrease. Why? Because now this d orbital will start filling. Okay. Next question is, why transition metal form large number of complex? So if you see, transition metal form large number of complex. What is the reason? First reason, they have small size of metal ion. The metal ion is very small, it has high charge density, and there is availability of the vacant d orbital where other elements can donate electrons or they can form bond. The last question, question number 15. The second ionization enthalpy of the chromium and copper is very high. Why it is so? So remember, in chromium and copper you have half filled and fully filled orbitals. So when you remove one electron, suppose from chromium and from copper you have removed 1 electron, that is called as first ionization enthalpy. But when you try to remove second electron, so this d orbital and this d orbital both are very stable because it is half filled and fully filled orbital. So when you will try to remove electron from the half filled and fully filled orbital, it requires large amount of energy to remove the electron. So that's why second ionization enthalpy is very high. Next question is, what is the composition of the mixed metal and give one use? So In lanthanoid, so you can use any one of the lanthanoid metal around 95%, iron you use 5%, and traces of sulfur, carbon, calcium and aluminium you can use. So result information of the mesh metal, and it is used for the magnesium based alloys to produce bullet and the shells. I hope you understood all the questions. So please like the video. If you have any doubt, you can write in the comment section. So see you. Bye.